Hello, I'm Darren Jolley. I'm the quality manager in the chemical test division, and I'm also the lead scientist and manager for the development of the Spitfire test fixture. Spitfire stands for Swatch Permeation Test Fixture Re-Engineered, and I'm going to walk you through some of the capabilities and show you the fixture and what we do with it. What we have is a fixture that tests pieces of material inside Swatch cells, and we test the permeation under chemical warfare agents and other ticks or toxic industrial chemicals. The fixture itself is housed completely in this environmentally controlled glove box. The glove box can operate between 50 C and minus 20 C, and we can run a test between those temperatures and humidities between dry, essentially no humidity, up to 70 or 80% relative humidity in the system. In our initial testing of this glove box and the setup, we can have temperature variations of less than a degree, and we've run the fixture at 50 degrees C and minus 20 C. And essentially, minus 20 C has never been done anywhere else that I know of on the face of the planet, which is really kind of cool. When we first saw that data and we were stable over 24 hours at minus 20 C, it was pretty cool. The fixture can test Swatch with liquid drops on it. We can test vapor concentrations in it, and we can quickly and easily adapt the configuration to deal with both non-permeable materials and permeable materials. So when we actually run a trial here, we bring a piece of material and we put it inside the little cup. The little cup is then coupled together and it's sealed with the red lever, and then we connect the lines, and those lines allow for airflow to come through the cup and out to our chemical detection system, which is the mini cams, and we can sample the cups over time and watch the chemicals slowly break through, and we capture the concentration of that breakthrough inside with this instrument. Okay, so the fixture is all controlled right here. We have a station with LabVIEW on it that controls the flows in the cups, the temperatures and humidities, the ventilation and flows in and out of the glove box. It's all controlled, and you can individually set parameters that are important to the test, and have the equipment dials it right in, and it also records the data in real time. You can pull up the charts and graphs at a click of a button, and you can essentially see what's going on the test. So we'll take all of this information and pull it together, and that becomes the data package that supports our test reports to our customer. So we originally decided to work on this fixture after running a test program called the Joint Expeditionary Collective Protection Program, where we had built several Swatch test fixtures that would disseminate vapor onto the materials that were to be tested. And we also were having fixtures that we normally use. The Avlag fixture has becoming old and obsolete, and we wanted to design something that we could replace both of those test fixtures and provide our division with a test capability that was unique, met the Army's requirements, and allowed us to operate more ergonomically and with less cost and expense to test programs. The reason this fixture is important is that protective materials, tents, shelters, overgarments, gloves, boots, anything that a soldier would use to protect himself against chemical warfare agents are tested in this fixture to make sure they meet the performance specifications that the warfighters specify, and we make sure that that happens so that they are safe on the battlefield.